Welcome back, everybody. First video of the new year, new school year at least. Shout out future me. Shout out 2020. Actually, no, I'll be doing this again in January. So shout out January, Mr. Laverick. Looking good today. Okay. I did that for my Algebra 1 classes, and I played that, and I had completely forgotten I did that. Like, I shouted myself out last year to myself this year, and it was like, I was like shocked by it. My freshman could not care less. They thought that was like the cringiest thing in the world. I was laughing. It was great. All right. So, a lot of people ask me, what do you learn in a statistics course? Right? What do you learn in statistics? Basically, everything that you think you know about statistics gets covered in chapters 1, 2, and 3. Okay? We go through 10 chapters. That's pretty much everything that you think you know about statistics. We cover it's probability and statistics. In chapter 1, I think I said this yesterday, where each chapter we will have a chapter assessment at the end of each chapter, and that's we will call that our chapter test. Because this is only a semester-long course, and because we go through 10 chapters, think about that. That's like a chapter test every other week. Okay. Some of the chapters are quite small. Some of them are a little bit more lengthy. Some chapters only have 2 sections. Some have 5. It just kind of depends on the chapter. But like for chapter 1, we actually will probably have our chapter test by the end of next week. But because it's only 3 sections long, I'll teach section 1 today. We'll teach section 1 tomorrow, 1 3 on Monday. Review a couple days, and then we'll take our assessment next week sometime. So it gets going pretty quick, and it moves pretty fast. But I don't think this is necessarily difficult material, especially this beginning stuff. It's not necessarily difficult because, again, this is the stuff that you probably already know about statistics. Chapter 1 is just a lot of review. Chapter 2 is all about this thing called descriptive statistics, which is basically like pie charts and histograms and bar graphs and all the different ways you can visualize. I think I'm kind of getting ahead of myself a little bit because we do define that here in this first section. And then chapter 3, if I'm remembering correctly, is all about probability. Is all about, maybe that's chapter 4. I can't remember exactly. But then we get into probability, and that's probably a lot of stuff that you already know as well. Like, what's the probability that I draw a king out of a deck of cards? And, but then we get into like, okay, what's the probability that I draw a king or an ace on the first pull, and a 10 or a 5 on the second pull, and combine that with rolling a dice. Like what is that probability that I have those things in sequence? So we get really in depth in that case. And then beyond that, it's like, okay, stuff that you probably never even thought you knew or thought you would ever need to know. We get into a lot of what's called inferential statistics. Again, we'll define that here again today, where we can make decisions about statistics based on surveys and samples and things like that. So, and that's really like chapters 4 on. Okay, so that's really the stuff that you think you know about statistics. It's probably chapters 1, 2, and 3, if I had to guess. I guess I don't know what your background is, but so a lot of today is going to be a lot of this first chapter, and you'll see a lot of this first couple sections within each chapter are a lot of definitions, a lot of things that like, okay, we need to set the ground rules, we need to set the building blocks, we need to set the vocabulary so that we can speak about these things. So what is statistics? Well, statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. What is data? Well, data consists of anything that you can observe, anything that you can count, anything that you can measure, anything that you can, any sort of responses that you may have. Okay? So data is just anything that you can collect, right? That could be, averages, that could be, like grades, that could be, temperatures, that could be numerical things, that could be non-numerical things, that could be like, what's your favorite movie? That's data. That could be, what's your, how much screen time do you have per day? That's data. It could be anything. It could be feelings. That's data. Like responses. Like how do you respond to this? That's technically data as well. Normally in our mathematical brains, we think data is just being numbers, but it doesn't have to be. It could be either quantitative or we'll call it qualitative data. Statistics, the science of collecting, organizing, analyzing, and interpreting data. That, honestly, takes us through the entire course. How do we collect data? How do we sample? How do we make sure that that sample is random? What are the different ways we could randomize that sample? How do we organize? How do we describe the statistics? How do we show you? Like, how do I present the data? That's chapter 2. How do we analyze data? Okay, so now we're getting into standard deviation, variance, things like that. How do we see what's going on within the data, and then interpreting that data. Now that's taking it to another level and saying like, okay, how do we make decisions on that data? How do we say, well, if the mean is this, what can we say about the data? If the mean is this, if the standard deviation is this, what does that say about the data? What decisions can we make? What feelings do we have about it? What spin can we create on it? Yeah. Population. We have populations, and then we have sample. I'm sorry about this dang watermark that's still on here. I'll try to move around some graphics if we need to. They said that was going to be gone by the first day of school. It's not. A population. Okay, whenever I talk about the word population, I am saying it's that is like all the total possible outcomes that you could possibly have. Whether that be an event like drawing a card out of a deck of cards, or that could be talking about taking a sample. Like it deals with not only the probability side, but also the statistics side. Like if I say the population is all students that go to Lake High School, that means that encompasses every single student that goes to Lake High School, no exceptions. Okay, so if you're going to say that I'm going to take a population and I want to talk to every person within that population, you must hit every single person there. Okay, it must include every single element within that set. Now, you can take a sample of that set. That's a subset of that population. Okay, you can take a sample, but we have to keep our brains different from what is a population and what is a sample. Reason being, a lot of the times as we move forward, we're going to have different formulas for population and sample. If we calculate population mean, is a population standard deviation. That's one formula. If we talk about sample standard deviation, it's a different formula. There's little tweaks to the formula. Okay, so we have to know what it is so that we can use the correct formula. So population is the overarching, all the elements of the data, every possible thing. Right? If I talk about the population of all the Harry Potter movies, that's all 8 of them, right? That's all of the movies. But if I say, okay, a subset of them, that's a sample. If I talk about all of the math teachers of Lake High School, right? That's every single one of us. But then if I say, okay, only the algebra teachers, that's a subset of that sample, right? So, or that's a subset of that population. That would be a sample of that population, okay? So, I've got 200 registered voters that were polled, and 56% of them expected to vote in the upcoming election. This is going to be really interesting, especially this semester, because there is an election this semester. I love to look at statistics and data, that are thrown out on the news, and hopefully they're all of them backed up with actual, actual surveys and things. But I love to look at like things that are said and things that are produced and things that are shown. Like, okay, a certain candidate thinks they're going to get this percentage of votes. Like nobody actually knows. This is just that what we call that an inferential statistics. But like this is going to be a good time. This is actually the first time I've taught statistics during an election. So I'm excited to kind of like look at those things as we go along. Again, we will not be talking about like the actual politics side of it. We are going to be talking about the statistics piece of it. Like, okay, what do the numbers say? And that's, I'll talk about that a little bit more as we go along, but really we're just looking at our math brains about it. We're not talking about our feelings about it, just our math brains. So 200 registered voters were polled and 56% of them expected to vote in the upcoming election. What is the population of this? What is the population?
Total registered voters.
Total registered, all registered voters. All registered voters. That would be the population. Okay, all registered voters. And I'm going to emphasize all registered, sorry about my poor handwriting, voters. All registered voters. That is the population. Okay. Don't say 200, because that's not necessarily, what is 200? That's the sample, right? I say that all of my registered voters is the population, and if I take 200 of them and poll them, that is my sample. Okay, my sample size would be 200, and I have said that we polled them, and 56% of those expected to vote in the upcoming election. We polled 200 people. 56% of those people said, yes, I'm definitely going to vote in the upcoming election. Okay, describe the sample data. Okay, so we would say 56% said they would vote, which equates to, okay, what is 56%? Oh, not divided by times. Of, what it was, 200? So 112. So 112 said that they were supposed to vote, said that they were going to vote, right? Now, does that mean that all 112 of those people will vote? No. Does that mean that 56% of all registered voters will vote? No. But that's what we're going to get into. How confidently can we say that 56% of voters of the population will actually vote, right? Because this is taking a sample to try to make an inference about the population, right? I took a sample of 200 to try to maybe guess something, to try to maybe predict the future about all of the registered voters. I take a sample to predict something about the population. You know, I take a sample of those 200 and say 56%, and say, okay, I could estimate, I could say that 56% of those voters, or 56% of the population, will probably vote, but not necessarily, right on, dead on. That's really hard to do. But we could get a range of values, right? And we could say with some level of confidence that this piece of data is accurate, right? Okay, so now we have to talk about what is a parameter and what is a statistic. What is a parameter and what is a statistic? A parameter is something that describes the population. A statistic is something that describes the sample. Okay, a parameter is a numerical description of a population characteristic. A statistic is a numerical description of a sample characteristic. And this is something that could be it could be average, it could be mean, right? I could say population mean, that's a parameter. I could say sample mean, that's a statistic. I could say population standard deviation, that's a parameter. I could say I could say sample standard deviation, that's a statistic. So if you're talking about a subset of the population, you would be referencing what's called a statistic. If you talk about a population value, that's a parameter, okay? So I would say, I think about it as the pieces go together. Parameter is population, statistic is sample, okay? Parameter is population, statistic is sample. So if you talk about a value that is describing the population, then you're talking about what's called a parameter. If you're talking about a value that describes whatever that value may be, that could be standard deviation, it could be mean, it could be variance, it could be whatever sort of thing we calculate. Whatever it is, if it talks about the population, that's a parameter. If it talks about the sample, that's a statistic. So, sample or parameter. The wording up there is a little weird. So are we talking about them as a statistic or parameter? That's really what we're deciding. First thing here. A survey of several hundred collegiate student athletes in the U.S. found that during the season of their sport, the average time spent on athletics by student athletes is 50 hours per week. Know this, side note, the book, I get almost all of these examples from the book, okay? The book always provides where they got that information, which is great. I think that's a great thing that the book does. I am not going to be referencing that as well, but they like parenthetical reference every single study that they use, and it's like all in the back, like there's a bibliography in the back. So know that all of these statistics, the ones that I get from the book, they're all real. They all have backup. They all have data to back them up. Okay, so this was actually real. I got this from the book. A survey of several hundred collegiate student athletes in the U.S. found that during the season of their sport, the average spent time on athletics by student athletes is 50 hours per week. Is that a parameter or a statistic? Is that describing the population, or is that describing a sample that was taken of that population? It is a sample, right? A survey of several hundred collegiate student athletes, right? That is a survey of, I polled some students. It's a sample of a population, so it's a sample. So therefore, I would call this a statistic, not a parameter. Because what is the population? What is the population? If I say that the sample is the survey of those several hundred collegiate student athletes, that's the sample. What is the population then? All collegiate student athletes, right? All collegiate student athletes. And we emphasize that all because that's the overarching big picture thing, right? Freshman class now, sometimes it can be a little ambiguous. The freshman class at a university has an average SAT math score of 514. In my mind, when I read this problem, I think that means that they took every single freshman at that university and found their SAT score and then averaged it. So in that case, if I explain it like that, is that a parameter or a statistic? Parameter, right? That's a parameter. Now, I could argue, we don't know, we would need a little bit more information, but what if I had said that this study was about, maybe I had said the freshman class at Kent has an average SAT math score of 514, and my study was about freshmen at Mac schools. Okay, well in that case, that includes Akron and OU and all the other Mac schools. So now, if I change that to say that, is that a parameter anymore? No, because now I've only sampled the students at Kent, right? We'll talk about what type of sample that is soon too, as well. So it's going to be important. I try to be as specific as possible, especially on my tests and quizzes, so that you know exactly what I'm talking about. So yeah, there's some ambiguity. I'm still tweaking some of my quizzes and tests. This is the 5th time I've taught this course, and some kids still find loopholes about certain problems where I'm like, yeah, I probably should have worded that a little differently. But I try to be as specific as I can on quizzes and tests so that that the answers are clear, at least. Okay, so now we're going to talk about basically what Chapter 2 is. Descriptive statistics. Descriptive statistics is the branch of statistics that involves organization, summarization, and display of the data. Okay? Descriptive statistics is the branch of statistics that involves the organization, summarization, and display of the data. This is like your unbiased, no feelings, strictly math brain presentation of the data. We are not drawing conclusions. We are not making opinions. We are not putting any sort of spin or any sort of slant on the data. We are not saying anything about the data. All we are doing is presenting it, letting the reader decide for themselves what they can draw, right? Just presentation of the data. That is descriptive statistics. Organization, summarization, display of the data. This is like, okay, if I create a pie chart, if I create a bar chart, if I create a histogram, if I create a box and whisker plot, if I create a 7-leaf plot, I'm not making any decision, not making any opinions on the data. I'm just displaying the data. That's descriptive statistics. Okay, next example here. Find which parts are the descriptive statistics in the following statement. I'm trying to move it away from the watermark there. A large sample of men aged 48 was studied for 18 years. For unmarried men, approximately 70% were alive at the age of 65. For married men, 90% were alive at the age of 65. Now, I bet you're thinking, well, this is trying to get you to think in a certain way, right? This is trying to get you to make an idea, make an inference about this situation, right? But let's just think about it as our descriptive pieces here. What are the descriptive parts? Okay. Well, the descriptive pieces was that 70% unmarried, 70% alive at the age of 65. Married, 90, right? 90% alive at 65, right? We're just describing what's happening in the data, right? I didn't cause this to happen. We're just looking and seeing what happens. Are you in your brains thinking, can you make an inference about that? Can you make an opinion about that? Like, are you really going to say that if you're married, you're going to live longer? I don't know. But that's a completely different branch of statistics, right? What we're doing in descriptive statistics is just displaying the data. We're not trying to give you any opinions on it. We're just saying this is what's happening. Make decisions on your own. When you make those decisions, that's when it turns into what's called inferential statistics. Inferential statistics is the branch of statistics that involves using a sample to draw conclusions about a population. Now, we're not going to get as opinionated about things. We're not going to draw opinions. We are going to use this thing called hypothesis testing to decide whether something is a valid argument or not. Okay? We're going to use hypothesis testing to say, okay, this is a valid statement or not. Okay. So that is more inferential statistics. Basically like this. I can say, if I took you guys in this room and I found your GPA, right? I found your GPA and I said, okay, the average of Mr. Laverick's statistics class is like I don't know, 3.8 or something like that. I don't know, just making it up. The average is like a 3.8. Could I make a conclusion about the entire GPA of Lake High School? And what confidence could I have in that statement? Right? Like if I said, I just sampled you guys and I found your average GPA, inferential statistics would be saying, okay, how confident can I be in making a decision and saying, like, I am 70% confident that the population average would be also 3.8, right? That's inferential statistics, taking something you know about a sample and being able to expand that to an entire population. See, there's all sorts of things that go into it too. Confidence, like how confidently can you make that decision? There's all sorts of, we'll talk at great lengths about this. Again, this is probably like chapter 4 or chapter 5, 4 or 5 onward, okay? We'll learn about hypothesis testing, how to decide whether an argument is accurate or not, or valid or not, but yeah. In the last example, guessing that being married is associated with a longer life would be using inferential statistics. Taking that next step and saying, making that decision of, okay, I'm now going to draw an opinion based on these statistics, based on that data. That's when it turns it from descriptive statistics into inferential statistics. Okay, when you put your own spin on things, it changes the game a little bit. A survey conducted among 105 boys and girls at Lake High School showed that 76% of the boys liked math class, while only 48% of the girls liked math class. Identify the descriptive aspect of that survey. Okay, so I would say 105. That's my sample, right? So I would say 76% of boys like math. 48% of girls like math. Okay, if this is what the data shows, that's what the data shows, right? You create that. If you find that data, I mean, numbers don't lie. If you actually do the survey and it comes out to be like that, you can't change it because that looks bad, right? But this is just descriptive, just finding the survey, just creating the survey, creating the sample, and showing what's happening, right? But what inference could you draw about that? And this is where it gets a little sticky. This is where it gets a little like, okay, you're really going to make that statement? You're really going to make that statement of, okay, boys like math more than girls like you? Ooh, that's a bad statement to make. You're getting a little tricky there. You're getting a little sticky there. So inferential statistics, well, I'm more of like a black and white type of guy. I'm more of a math brain type of guy. I don't like to make opinions about things because somebody's going to disagree with you. I'm like a more descriptive statistics kind of guy rather than an inferential statistics kind of guy. I don't really like to make those opinions because someone will disagree with you and someone will have opposite opinions from you, and I don't like to fight with people. But you can create inferences based on what you draw from surveys. And there is a piece to it about, again, how much confidence can you make in that statement, right? And then you have to go back and look about, okay, we will take the process of, we look at the data, we make inferences on the data, and then we say, okay, was there any bias in my sample? Like, how did I draw my sample? How did I create my sample? Did I only choose girls from a certain class? Like, how did I sample the girls? Was that from a class that had a really bad teacher? Was that from a class that had, maybe it was a course that, like, a low level course that they really hated math, Maybe it was something that they struggled with, was that where they were drawing that sample from? Where did I get the boys from? Was that from an honors class? Because usually honors kids like math a little bit more, because they're good at it. Where did I draw this sample? So you have to kind of take some thought about, okay, look back. Once you're at the very end of things, loop back around, analyze your process to see, okay, if I could do this again, would I change anything? If I could do this again, could I make my sample a little bit more random? If I do this again, how likely am I to get my same exact pieces of, or my same statistics that I had found, right? Think about what biases there are, all of those different things. So we're going to go through this process. I think I talked a little bit about it yesterday, where we will have a project that runs the entire semester, where you will actually create a question. You will ask, you will poll, you will create a survey, you will ask at least 30 to 50 people your question. You will see what is happening in the data. You will display that data. You will make inferences about that data as we go along. And then in the end, I will ask you to evaluate your process. And I'll ask you to be honest in the evaluation of your process. How did you create that sample? Was there any bias to that sample? Right? Was there any? Was that sample truly random? And we'll talk about what that means in the next coming sections. We'll talk about all sorts of things that we'll have to look back on and say, could I have done my project in any different way to make it come out a little bit better? And even that statement is a little bit hard to say, because what is better? Did you have some sort of idea of what you wanted to get out of the data? You don't want to have any self-fulfilling prophecy where you're like, oh, I think the data is going to be like this, so it should come out to be like that. Well, that's a tricky area too, because if you think the data is going to come out in a certain way, then you've got a slant on you got an own bias about your own data, right? So I think that is it for today. Yeah. So we've learned a lot of basics about a lot of vocabulary about some things. Just as a reminder about the homework problems. The homework is up here, page 6 to 8. We got 1 to 10, 11 to 41 odd. But again, remember, that is just the suggested problems. These are the required problems. Now, when I write it up on the board here, I'm going to write the required problems up on the board. So up here, I'm going to say page 6 to 8. And then say 1727. Oops, not through. 1727, 35, 41. And that's it. 4 problems for this first section. Nice and easy. Yeah? So if you want to, bell rings at, what's the third period? You got about 10 minutes. Honestly, it's just 4 problems. If you want to jump on your computer, get up there. If you want to just borrow a book, just for now, you can do that as well. They're the skinny books up there, not the binders. Okay? But again, the PDF copy of the book is on Schoology. The hard copies are up there if you'd like one. You can do that. Please do not come up and get your phones until the bell rings.